Hello everyone. Today in this next session, now we will see what are the different types of the ignition system which are utilized in the IC engines. Before going for the types of the ignition system, I would like to recall this ignition system concept again. A system which initiates the combustion process by a spark inside a engine cylinder is known as ignition system. So this is what we have seen in the last session, that what is the ignition system, what are the requirements of the engine ignition system, what are the different characteristics of the engine ignition system, then what are the basic components of the engine ignition system. Now we will see what are the different types of the engine ignition system. So generally the ignition system is having the three types: battery ignition system, magneto ignition system, and electronic ignition system. So we will start with the first one, which is the battery ignition system. So in the last session we have seen that there are certain basic components of the battery ignition system. The very first one, which is the battery, which is generally of 6 to 12 volts. Then we are having the ignition switch, which will turn on or turn off the ignition system of an SI engine. Then we are having the ignition coil, which is comprises of primary coil and the secondary coil. The primary coil, which is generally of 200 to 300 turns, which are of 20 gauge copper wire. Secondly, we are having the secondary coil, which is of 21,000 turns of 40 gauge wire. So this is what we are having together, an ignition coil. Next, we are having the contact breaker. Here, contact breaker exactly having the making and breaking operation for the ignition system. Then we are having this one as the distributor, which exactly gives the high voltage potential, likely of 20,000 volts to the 30,000 volts towards the spark plug. So this is what we are having the general introduction or the simple circuit of the battery ignition system. Now we will see how battery ignition system is working. As you can see in the schematic, we are having a battery, ignition switch, a ballast resistor, followed by the ignition coil, then a contact breaker and the condenser, or you can say capacitor. Then we are having a distributor with its rotor arm, and then at the end we are having the spark plug. These are the basic components with their connections are shown in this diagram as a circuit diagram. Now let's see how it will be operated. So here, when an ignition switch is turned on, the primary circuit gets closed and the current starts flowing from a battery to a ignition coil. In primary circuit, a ballast resistor is provided, which regulates the flow of current, which helps to avoid overheating of the spark plug. Now this current flowing in primary circuit is the primary current. This primary current sets up the magnetic field around the iron core of the ignition coil. This current flow through contact breaker when contact breaker points are closed. Now when ignition is required in spark plug, camshaft operates the cam in the contact breaker. Because of the cam, the contact breaker points now gets open, and then it restricts flow of current in contact breaker. Now as contact breaker points are open, this current will flow to the capacitor, because of which the capacitor gets charged and primary current falls, which makes the magnetic field also to get collapsed. Here the change in magnetic field generates current in the primary coil, which flows in the same direction as that of the primary current and charges a capacitor at quite higher voltage than the battery voltage. Now see, further current flow will not be occur from battery once the capacitor gets charged. Now, because of the above action, capacitor now discharges into battery, which reverses the direction of primary current as well as the magnetic field. Because of this rapid reversal, a high voltage is developed in the secondary coil. Now, this high voltage is transferred to the distributor using high tension cables. Here, in the distributor, high voltage is transferred to the distributor rotor arm, which rotates according to the camshaft. In the distributor, whenever the distributor arm comes in contact with the distributor point, high voltage jumps because of the air gap to the distributor point. Now, this high voltage is transferred to the central electrode of the spark plug according to firing order and ignition timing. Inside the spark plug, a voltage difference is generated between the central electrode and the ground electrode, because of which the gases between the two electrodes are getting ionized and becomes the conductor to allow a current to flow between the gaps, and spark is generated. And this spark is exactly utilized to initiate the combustion process in SI engines. So this is how the battery ignition system is working. Now we will see how magneto-ignition system is working. Before going for magneto-ignition system, let's see how magneto is working in this system. Generally, a battery and ignition coil of a battery ignition system is replaced by magneto in a magneto-ignition system, and rest of the arrangement is same as that of the battery ignition system. Basically, magneto-ignition system having the magneto, which is having a fixed armature with primary and secondary winding. Also, it is having a rotating magnet, which is rotated by a engine itself using a cam. Here, when magnet start rotating, a magnetic field is generated in the soft iron core of the armature. Now, because of the change in magnetic field, a current and voltage is generated in both primary and secondary windings. So, in this way, without battery and ignition coil, a magneto produces a primary current and voltage by itself. Now, we will see actual operation of the magneto-ignition system. So here, when magnet rotates because of the engine cranking operation, a magnetic field is getting produced and it changes continuously because of rotating magnet. Because of this change in magnetic field, a voltage and current is produced in both primary as well as secondary winding. In first case, this current now flows through contact breaker, as contact breaker points are closed and allows current to flow through it. But when ignition is required, distributor camshaft operates the contact breaker and opens the contact breaker point, so that now current will not flow through the contact breaker. This current now flow through the capacitor or the condenser, and it charges the capacitor at higher voltage. Now, because of this above action, capacitor now getting discharged and reverse the direction of primary current as well as the magnetic field. Now, this rapid reversal causes high voltage to be developed inside a secondary coil. Now, this high voltage is transferred to the distributor using the high tension cables. Here, in the distributor, this high voltage is transferred to the distributor rotor arm, which rotates according to the camshaft. In distributor, whenever distributor arm comes in contact with the distributor point, a high voltage jumps because of the air gap to the distributor point. Now, this high voltage is transferred to the central electrode of the spark plug according to firing order and ignition timing. Now let's see what happens inside the spark plug. Inside the spark plug, a high voltage difference is generated between the central electrode and the ground electrode, because of which now the gases between the two electrodes are getting ionized and becomes the conductor to allow a current to flow between the gap, and then spark is generated. So in this way, the spark which is generated is exactly utilized to initiate the combustion process in SI engines. So likely this is how the magneto ignition system is working.